there's going to be two classes of Rust users, which is people who are aware that they're using Rust and people who are not aware that they're using Rust.
Many companies would be concerned having to spend too much of their time doing these things versus focusing on their product, right?
There's not a lot of like unknown, where you're like, oh my God, I'm the first person ever bumping into this bug. What's going to happen? But if you're not doing something very exotic, you're on the happy path, I think you can definitely very easily, piece things together and get running. Rust is the most expressive type system you find in, mainstream programming languages without going into the family of strictly functional programming languages. In reality, Rust gives you the most flexible type system around.
Hello everyone, I'm Marco from Main Matter. We are a web engineering consultancy, and last year we made a strategic decision to add Rust as one of our focus technologies with a goal to help teams adopt Rust and succeed with it via workshops, mentoring, and team augmentation. And we also run Eurorust, the conference for the European Rust community, and tickets are still available. It's this year, October 12-13. Today, we want to talk about backend development with Rust and the state of it. And I'm joined by Luca Palmieri today, author of Zero to Production in Rust and senior software engineer at AWS. Hi, Luca.
Hi, thanks for having me.
Thanks for joining today. Could you maybe introduce yourself a bit?
Sure thing. My name is Luca. I'm an Italian in London. And I've been doing Rust for 5 years at this point, since 18, 19. Done a variety of Rust use cases, from like numerical computing to more recently backend development in general, web development, either professionally and in the open source community. So I've both maintained and written production services previously through Layer. Now I'm working on the Rust ecosystem at AWS. And as you mentioned, I brought Zero to Production in Rust, which is a book on getting people introduced and up to speed with Rust, backend development, and in general, the ecosystem around those topics. I also maintain a bunch of open source crates and, travel to conferences from time to time. So you might have seen me around.
Do you want to talk a bit more about the book, maybe? Sort of who's it for? What kind of approach does it have?
So the book was born as an introduction to backend development in Rust from a very material type of need. Like, we were adopting the language at Layer, the company I was a principal engineer at the time, and we needed to scale from an initial team of like 3 to 4 people building a POC to, towards the end, 40, 45 engineers writing Rust full-time. And obviously, extensive one-to-one training on the language was no longer possible because we didn't have enough people to act as teachers. And so to scale yourself, you do what you always do. So you write things down so that people can read them, and then they come to you and ask for questions. What I identified as a gap was that there was a lot of material in the Rust ecosystem about Rust as a language. So, you had the Rust book, there's programming Rust, there's Rust in action, various flavors of getting started with Rust.
Yeah.
And then you are like, well, now go and build the rest of the how. Like, go and figure out web development by yourself. And so there's a bunch of frameworks. Most of the frameworks are, not necessarily very comprehensive. So they're not opinionated about all the bits and pieces that you actually need to put together an application. And then you have asynchronous programming, which was very new at that point in time. Like, you didn't have a lot of books and like how to use it productively. And to do backend, you need to piece all these things together. And obviously, if you're just getting started with Rust, you're not necessarily in the best position to understand what to pick, what are the trade-offs, how the things get together. And generally, like, you want to get to productivity as fast as possible. And that's where the book came in. Like, the book is fundamentally a long workshop where you, the reader, and I, the author, are pair programming together, writing a Rust service as if that's going to go to production. So thinking about, observability, thinking about testing, thinking about security and how to use the database and migrations and deployments and Docker containers, but all the things that you need to know if you want to use Rust for real on some projects that has commercial value. And that's worked pretty well, first internally as a way to onboard my colleagues. That proved to be a good ramping path. And then externally, it seems like that need was shared by others. And so that's how it came to be.
I have to say, I read the book myself, or like I'm 50% done, sort of, and follow through it. And I really like the sort of hands-on, pragmatic approach. And I think for many people, sort of that's just the thing you want to have. Let's just see how we can build a real thing, right? And before we focus more on the points that you mentioned regarding the state of the ecosystem and so on, let's maybe, or maybe you can share some of your experience with working with Rust and TrueLayer and AWS for 5 years, which is very, very long, obviously, in the Rust world.
Yeah, sure thing. They're very different experiences, I would say. Like in TrueLayer was very much on the front line of writing services, and AWS are more in the building tools type of part of the company, where I'm building tools that people are using to build services. So let's start from TrueLayer, which probably is the closest to what people experience on a day-to-day. TrueLayer used to be primarily a C# user. So most of our internal ecosystem was written using .NET Core in C#. We had 50, 70 services. So your distributed service-based architecture, microservices for the newer kids. And we were experiencing some problems, which I would describe as a variety of different problems. Some were related to code maintainability and correctness, mostly with respect to error handling and nullability, which in C# you have unhandled null reference exceptions, and you have exceptions for error handling. And that was causing a lot of issues as code bases were getting older, and you had a lot of spooky action at a distance, as exceptions tend to make code bases into. Then we had concerns about scalability and latency. We operated a payment platform at that point in time, and as anybody working in e-commerce can tell you, how long it takes to do things has a material effect on people using your product. And so you generally want it to be snappy, and you want it to be snappy in the worst possible case. So there's a lot of looking at P99s and P99s. And last but not least, we wanted to scale to higher amounts of traffic without necessarily breaking the bank on infrastructure builds. And it happened to be that this perfect storm of conditions met with Rust achieving production readiness around the async story. This was late 2019, early 2020. And we were about to start writing a new system, which involved like ledgers and banking transactions and a lot of like very sensitive type of material. And I happened to be the architect of that system, and we decided to trial Rust out with a small team, which was made of me and a couple of other engineers who had never used Rust before. So we watched, at the same time, we wanted to check, can we do this? Can we do it well? And can we train people in this new language, which looks very cool, but it's basically impossible to hire anybody who has any, real experience using it, which was a very material concern at that point in time.
Yeah. And that's like 3-4 years ago, or?
Yeah, that's 3-4 years ago. I think right before the COVID pandemic.
Okay. It is easy to remember.
Yes, it's very easy to remember. And so, all of this was done remotely for the first time, which was interesting as well. Mm-hmm. But that service went well. The product at launch was commercially successful. The technology helped very well. The people upskilled faster than we expected at the beginning. And we've been, Ray has been investing in that area. And when I left, which was roughly a year and a half afterwards, we had 45 engineers, if I remember correctly, working on Rust full time. And we were operating something along the lines of 100 Rust microservices, which was, I think, one of the most sizable deployments in London that I'm aware of from the community. It was a win on so many different levels. So job satisfaction was one of those, like people generally enjoyed working with the technology. So that was obviously something we accounted for. Hiring was also much easier than accounted because we were able to attract people who were interested into Rust. They might have had, previous experience, usually on the hobbyists side of things, but they were very keen on translating that into professional experience, and they brought with them usually domain knowledge. So they were very strong backend engineers who didn't have, hard time moving into the tech. And generally speaking, from a product, performance and impact, all our Rust services were very easy to operate, very easy to scale, usually didn't require to scale pretty much at all, and made for very smooth on-call and operation experience, which obviously when you're doing payments and high reliability is a large part on what you offer. I usually say how often does it happen that you go somewhere and you try to tap your card to pay something and it doesn't work? That's a very rare occurrence. That's the level of reliability that you want to have. And if you're not there, then you're not a viable payment solution. And so, yeah, it was a success. We scaled it up. As far as I know, it's still going stronger since I left. So, the numbers are not going down and the investment is not receding. So it's not me. With me out of the picture, self-sustaining, which is positive. So overall, I think a good success story. AWS is a different type of bag instead. AWS as well has been investing into Rust more or less since the same period of time, as far as I'm aware. And they had pretty substantial amount of production Rust currently running. Some of these projects are visible externally. Firecracker, which is the hypervisor, the powers Lambda, is one of the most noticeable. But bits and pieces of Rust are making their way into pretty much all AWS critical products. And so AWS has chosen to spin up earlier last year a team called Builder Tools for Rust, which is around building Rust service framework and libraries that people can use inside AWS and also outside to improve the experience of building with Rust and building things that are reliable and easy to operate. Most of the work that we do is open source, so you can find it if you look for SMIDI Rust on GitHub. And it's the implementation of this SMIDI interface definition language, which is, you might say, AWS's versions of protobuf that they use to describe all their services and also to generate the AWS SDK, which as well, the AWS SDK for Rust is an in-progress project that we're currently going for. And it's interesting to see, obviously AWS is very different from TrueLayer, but actually not that different. TrueLayer was a C# shop. AWS is a very, Java-heavy environment. The languages are very similar. The challenges are very similar. So there's a lot of garbage collection tuning. There's a lot of object-oriented paradigm moving into Rust, which is slightly weirder and slightly different. A lot of techniques that don't match up and how you do testing and how you do things. So all in all, I've actually found it not too different. Obviously, the scale is completely different, but that's different about it. Different axis.
So you mentioned before how you built sort of the first services in Rust at TrueLayer 3-4 years ago or so, right? And I think sort of in terms of Rust history, that's sort of in its infancy essentially, right? When I think particular sort of for building web services, I think the situation was sort of not, or sort of the ecosystem wasn't as mature as it is yet, right? So I assume there was a lot to figure out, how do you structure applications, how do you test whatever, right?
We did a few feasibility POCs before actually committing to do the new project in Rust, and this was in 2019. We were trying to make sure that we were not going to be blindsided. So going to a major project, which is a pivotal business initiative, you don't want to find yourself halfway through that you're there's no production ready driver to use, for example, RabbitMQ, which was a key part of our architecture. We're not going to build an implementation of the MQP protocol from scratch because that would, throw us massively over budget and over timelines. So we did a few small applications that were demo-like applications to check crates, maturity, how easy was it to integrate all of them, patterns, how do we do testing, how do we containerize these applications. And all in all, the check came out positive. We identified some criticalities, obviously. This was very early and a lot of crates were not necessarily super stable. Especially this was right after async await got stabilized. So there was a lot of churn in a lot of libraries to become async await native, so to say. So a lot of versions in flux. We have lived the entire, Actix Web 3.0 to 4.0 migration, which was very interesting. But these were deemed to be workable obstacles. As in it's a minor annoyance, but it's not a showstopper. And so we did an assessment and we're fine with the risk. Let's plow through with this initiative.
And then I assume sort of you ended up building sort of your own sort of framework on top of Actix, encoding all of the practices and patterns sort of you wanted to standardize on.
Kind of. I think we built mostly components. I think around Actix, so very opinionated way of doing logging, for example, very tight integration with the OpenTelemetry standard, which was what we built everything around inside TrueLayer. There are other areas where we built fatter like layers on top of the open source libraries. For example, when it comes to RabbitMQ, we developed our own event handler framework on top of Lapan, which is very close to what Actix look like, but for doing RabbitMQ messaging. And that's because the gap with respect to the ecosystem obviously was larger, and our needs also were a lot more bespoke. So we wanted to do things in a certain way. We generally tried not to go too fat in like over layering for primarily 2 reasons. If you want to build your own framework, there are situations where that makes sense as a company, but you need to stuff it. Like who owns, this custom build internal framework? If the answer is no one, then the way that framework evolves over time can, lead more problems and solutions. And so you want to be a little bit careful there. And the second one was, where possible, we try to work with upstream. So bug reports, we contributed a fair amount of fixes. When we wrap things, we usually open source them. So the request middleware, and there's another library called Ginepro that came out from us, which was a way to add retries and middleware to request, the popular HTTP client, which you can find on GitHub. And Ginepro was us contributing gRPC client-side load balancing to the ecosystem, which was not... it was supported in Tonic, but not as easy as you would want that to be. So generally, we prefer to work with upstream. So try to give upstream fixes and patches. And if some functionality makes sense, for the library we're using, try to upstream that out. Sometimes we wrote our own libraries where that was necessary. And if they were not layer specific, we also open source those. So request middleware is an example when we added the possibility to intercept requests going out and do pre-processing. And Ginepro was another one where we added client-side load balancing to Tonic in order to be able to use gRPC in Kubernetes, which was a little bit of an unsolved problem at that point in time. But yes, like you end up customizing, like you end up having your own, very bespoke internal recommendations, which is not necessarily a framework on top of the framework, but it's like we use it in a certain way. And like that's the way we configure it. That's the way we lay out the project. That's the way we do configuration, which is sometimes by convention, sometimes encoded into a crate.
A framework encoded into documentation.
Meta framework, I think, is the more some people would use these days.
I think, though, the interesting question is sort of how do you see the ecosystem has evolved since then, and is sort of that level of sort of being involved with the open source community and writing your own libraries and so on, is that still something that you're committing to when adopting Rust, or is it a bit more stable, sort of where it can be sort of more like a consuming member of the ecosystem versus an active?
Depends,
because I guess many companies would be concerned having to spend too much of their time like doing these things versus focusing on their product, right?
I would say, the classic non-answer, which is it depends. And I would say, if you're doing something not particularly exotic, you're writing your REST API on the backend that's talking to a Postgres database and perhaps has a couple of queues attached, 99% of the time, like you don't have to worry about upstream. Like the features that you need are going to be available. At this point, they're fairly battle tested because a bunch of people like us, have gone there before, found them, fixed them, or at least if they're not fixed, they're known. So that's also another big divide, which I think people need to keep track of when they discuss new technology. It's not just about, does it work? Do we know when it doesn't work? So if I have an issue, is that issue well known, or I'm the first one discovering this problem? So I would say at this point in time, like libraries have been around the block in Rust for a couple of years with production usage. You know what they know how to do, what they don't support, and that's well documented, and you find those initials and documentations. And there's not a lot of like unknown, where you're like, oh my God, I'm the first person ever bumping into this bug. What's going to happen? But generally, like I think, as I said, if you're not doing something very exotic, you're on the happy path, I think you can definitely very easily, piece things together and get running. If you're doing something more bespoke, where you're taking some libraries perhaps to the extremes of what they've been tested for, which can be, dusty corners in the feature sets when you're using some stuff that is not necessarily common, or you're pushing them to levels of scale that have not been pushed before. So trying to get high performance, which perhaps that library hasn't been tested for. then yes, you might find yourself into situations where you need to patch upstream. But at the same time, if you're doing those things, you usually have the capabilities to contribute upstream. So you're a different kind of user. You're a more sophisticated type of user, and you should be able to get yourself out of whatever pickle you find yourself into.
Yeah, that's a fair point. That's a fair point. I think that leads to a next question, though, which is sort of what are use cases or what are scenarios sort of where Rust makes sense, and the sense also sort of where it's worth paying the price of potentially having to do that work that you talked about, and what are maybe scenarios where you're maybe better off using something else, right? Something more like established.
Yeah. So I'll preface that by saying that today, but perhaps even more so in the future, there's going to be two classes of Rust users, which is people who are aware that they're using Rust and people who are not aware that they're using Rust. And I'll explain what I mean there. So people who are aware of using Rust is people who, open their IDE, see Rust code, and write Rust code. And we're going to talk about them. The other class is people who are writing in other languages. And I'm primarily in my mind talking about Python, but I'm seeing these happening a lot also in the JavaScript ecosystem, in the Ruby ecosystem, and in the Elixir ecosystem as well, where Rust is becoming the de facto language for high-performance modules, replacing C, C++, Python, Python's version of C, to do like NumPy, to do pandas, and to do a bunch of other stuff, or to do the tooling. So we see that a lot in the JS world when like SWC, it's Rust. Like you might not know you're using Rust, but it's Rust. Raf, the linter for Python, which is now climbing like with a vertical stars count on GitHub, that's Rust. The cryptography library in Python that you don't know it's Rust, that's also Rust. And I think that is just going to grow exponentially. And I think that's actually what's going to bring Rust to the masses, if you want. It's going to be in almost every tool where you need a ounce of performance, and you might not be aware that it's there, but it's there. And so that's great. And in a lot of fields, that's going to be enough. Like you're not going to need to cross the chasm and say, I need to go and write Rust myself. So for example, I worked in the numerical community in Rust for a few years. And now Polars has become a major Python data frame library, which is written in Rust. And usually I would suggest you use it from Python because you get all the tooling that you get from Python to do data science, and you get the notebooks, and you get the fast feedback loop when you're trying to do stuff and you don't have to compile. That works handsomely. If you need to productize a complex data pipeline and you want to make sure that it's robust and you prefer using types and a bunch of other things, then perhaps you want to use Rust. But for most use cases, probably you're fine with Python. Now, where does Rust, direct usage make sense? And I think that is a slightly different cohort of people. Now, generally speaking, I think Rust has been held back by its reputation for being a system programming language, because that leads to a very strong association, at least emotionally, with like C and C++, which for myself, and I know a lot of other dads, is I don't do that. That's too difficult, that's too complicated, I don't touch, that part of the stack. While I think Rust is a fairly high-level language. Like, it's not very different from programming in Python or programming in C#. It brings some new concerns into the picture. And the concerns are, some are intrinsic to the language. So you need to care about how stuff is laid down in memory. So you need to care if something is a vec instead of being an array, because one is on the heap and the other one is on the stack. And this means that a bunch of types are different, and you might take another reference here or do something there. It's newer, so it's more immature. So obviously that's a concern. That's not necessarily a library for everything you might think about doing. But at the same time, it gives you a lot of control to do things that usually are very error prone. So error handling is very nice because it's functional. So you do that with results. Nullability is encoded in the type system. You do that with options. Multi-threading is a lot easier in the sense that it's much more complicated to expose yourself to data races because the compiler doesn't let you write them. And it's very explicit on like where stuff lives and how you handle that level of concurrency. So all those things make it so that if you are a solid backend developer, and especially if you're writing in a statically typed language, like, C#, Java, variety of the sorts, the jump to Rust is not that dramatic. But the performance implication and the stability implications that you get from jumping over the fence usually make that very much worth it if you're seeing some level of traffic or if you're concerned about the responsiveness of your program. So I usually see initiatives to adopt Rust when people want predictable performance, not necessarily high performance. They want predictable performance, which means
saying no GC breaks.
Exactly. When your P99 is a number, and it's generally that number, like it doesn't spike, and you're like, is this spike okay? Is this spike bad? Do I need to get worried? At what point do I page an engineer? It's like, our P99 is a line, which is under constant load. It's here. And I know if that spikes, something bad is going on. And so it's a lot easier to manage the software because you know where to alert, you know where to scale. Because you're like, okay, I've battle tested this service, I've load tested it. I know that it can handle a certain amount of TPS. Then I know that I need to set, my auto-scaling limits here, and here, and that's going to go well. The other one is also when you want to cut cost. So if you are managing a fleet of services, so this could be a classic server full deployment like a Kubernetes situation or an ECS on AWS, those things have a cost. And usually you try to keep them fairly over-provisioned because you don't want to run into problems. But then if you switch to Rust, suddenly you can cut your fleet size by 40, 50, 60, 70%. I've seen those numbers like in real projects where people through layer and elsewhere switched over some services from one language to the other.
Yeah.
And if you're doing serverless, that's the other one that I see, for example, a lot inside AWS. Since serverless is built on a milliseconds basis, if your service is fast to start and fast to execute, then your infrastructure bill also goes down. And generally, you mitigate a lot of the Lambda, cold start problem just because your service is so fast that you don't feel the cold start as much. And so you're able to offer an experience which is almost as responsive on, a server full Java application, but actually you're running in Lambda and you have all the startup cost, but just the user doesn't see the difference.
I think, that's a very interesting point, right? So like Rust offers sort of access to like C-level performance for people who had no access to it before because nobody would dare to write C code, right? But it's not a C replacement because, like you said, it's a modern language and it's an expressive language and it can be used in like many different cases as well, right? But I would like to get back to something you said earlier, which is not performance and efficiency. I think that's clear anyway. Rust gives you that, but reliability and stability, right? Sort of like option type, result type, and so on. No null reference exceptions and so on. I think that is something that is often a bit overlooked, maybe as a big advantage to like whatever Python, Rust, Python, JavaScript, Ruby, Java, C# or so. They're all sort of by nature maybe not as reliable and as stable as any application you write in Rust is probably, right? And maybe you have some experience to share because you said at TrueLayer you had C# and Rust. Like was there maybe a notable difference in terms of error rates and production or so?
I would say there was. Now I don't come, with the receipts, so you need to take that as an anecdotal data. The way I reason about this, and I 100% agree with you, I think, once again, a lot of people hear Rust, then they do system programming, and then they do performance in their minds. Bum, bum, bum. But in reality, Rust, a lot of people use Rust because of the type system. The way I usually frame it is Rust is the most expressive type system you find in, mainstream programming languages without going into the family of strictly functional programming languages. So if you're not using OCaml and you're not using Haskell, in reality, Rust gives you the most flexible type system around. Now, why does that matter? It matters for two reasons. What was it? Software engineering is programming integrated over time. Like every time you're doing a project of some kind, the project is gonna, if it's successful, obviously, it's gonna outlive its creators in a company because the creators move away, they move to another project, they move to another company, they retire, whatever. And it's usually gonna face high churn in the people looking over the project. So a lot of people are gonna on board, and they're usually gonna be of vastly different levels in terms of skill sets. They might be more junior, they might be more senior, they might be very inexperienced with the tech stack, they might be very experienced. And all of them need to be able to contribute to the code meaningfully, introducing new functionality without blowing up production environments. And ideally fast. That's usually also one of the equations people care about. We want to do all of this, we want to do it fast, and we want to do it right. Now, the thing about dynamically typed programming languages, so like Python, JavaScript, I have experience with Python on fairly big code basis because I come from the numerical ecosystem, and that's the language. Python is great, but once you scale it to a big code base and you don't have types, so you're not using progressive typing, which helps to an extent, suddenly you need to keep the entire code base in your head. Like every corner you touch, which is used by multiple places, you need to remember all the places. And you need to know what assumptions they're making about the stuff that's going in, the stuff that's going out, and the exceptions that are coming away. C# and statically typed languages make that a little bit better because some information now it's in the type system. And what that means is that the compiler reminds you of that. So, if something takes an integer and you transform it into a float, suddenly the C# compiler is going to be, this is not the same thing, and this caller here is broken because that expects this to be an integer. But they don't do that for nullability. Well, C# has started to introduce progressive nullable annotations, but it's going to be a long journey before you have 100% coverage of standard library, ASP.NET Core, and the entirety of the ecosystem. Good luck with that. And you don't do that for exceptions. You can do that in Java with checked exceptions, but the fallibility angle of a function interface is unexpressed by the type system. So this function has an input and an output. It actually also has exceptions, and the exceptions have types that you rely on to catch them, perhaps, 7 layers above in the stack inside a certain program.
Yeah.
But they're not part of the interface. So if tomorrow, instead of, raising, invalid data exception, you raise corrupt data exception. Now, suddenly, some error handling path I above is not triggering anymore because the type of the exception has changed, and now you're going down a different path. And you don't know that if you're new to the code base because perhaps you never opened that file. You don't even know it exists. And that's where, the over time integration of programming comes into the picture because, that a junior engineer is going to come into the code base and try to make a change. And they are not going to realize that this is going to break something else because it's booking action at a distance. And the machine-assisted reasoning is not there to keep them safe. And so it might be spotted in a code review, but most likely won't because you're going to look at a change set, and unless you touch the other parts, recently you don't remember. And suddenly now you have a bug in production. Or if you're unlucky, you have an outage or you have a security incident because something that needed to be checked to be now is not being checked, and some keys are not what they need to be, and suddenly a bunch of data is going to the wrong places. This in Rust doesn't happen because nullability is in the type system, error handling is in the type system, and generally, this makes the compiler more annoying, as in it's constantly telling you, you can't do that, you can do this, you need to handle this error there, but that's what you want. That's the feature. And that's what helps you scale your capabilities as a programmer because you can tackle bigger things because you can offload part of the cognitive load of looking at what you're looking to the machine and say, if I, by mistake, introduce a data race, compiler gets me. It's not going to compile. Fine, then I'll refactor it out. And also, there's a myth that needs to be a little bit dispelled. You interiorize a lot of these patterns over time. When you start writing Rust, you're constantly getting reminded by the compiler, can do this, you moved out of that there, this is not possible. But after a few weeks, you just start to do things right because after you've been reminded, 700 times, you see it I can't do that. Oh, no, I need to structure this way because otherwise I'm going to have that problem. So that constant bickering with the compiler mostly goes away, but the compiler is still there to catch you when you are daring to do more complex things, which I think is also an underexplored aspect of Rust. Since you have the safety net, you can be more audacious. And that can be trying to make something parallel that you wouldn't have done in Python because it's too complicated. Or trying to write a piece of software that it's in a part of the stack that usually you wouldn't touch, like networking. It's like, that's specialized. I don't do that.
Yeah.
And I find that nice.
Yeah, that's my experience as well. And the reassuring thing is sort of, you don't have to run those things to like figure out whether they work. You just need to compile them, right? And then they like very, very likely work. Right?
Yeah, you write tests for like acceptance criteria. You don't write tests to say this function is going to return a validation error if it gets an integer.
Yeah.
Or this function is going to return this exception if I do this specific thing.
I would like to close with a bit of an outlook, sort of an outlook. What's going to come to backend web development in Rust? What are the current priorities sort of that need to be explored, or that maybe like the ecosystem people in the community are working on, and sort of like, not a prediction, but a bit of an outlook, sort of what situation might we all be in like 1, 2, 3 years in the future. So, and I know you're also working on your own open source project, which is like trying to answer some of those questions as well. So maybe you can share your thoughts on.
Yeah, let's tackle these, I think, in stages. So there's one chapter here, which is Rust the language and like Rust the standard library. Obviously, the backend ecosystem is one of the primary users of anything which is asynchronous, because that's the type of style of programming that ecosystem has chosen. Whether we like it or not, we think that makes sense is a conversation for another time. What this means is that this is the part of the ecosystem that is more acutely feeling the fact that async await was shipped in Rust as an MVP in 2019, and a bunch of parts have not been fully fleshed out just yet. And I'm referring in particular to being able to switch one async executor for another. So for people who are not as familiar with the Rust machinery for asynchronous programming, the standard library defines interface, which is the future trait, but then you need to bring your own async executor as a library. And right now, it's not as easy to say, well, today I'm using Tokyo, tomorrow I want to use small RS, let me just change that and everything is going to keep working. It's not, because things make assumptions as to where they're being run and what is available and like a bunch of other things. There is a problem. Other problems come from the interaction of async with other parts of the language. There's a lot of discussion these days about keywords generic, generators, all sorts of things which are related to these, streams, async iterator, and so on and so forth. I expect all of that to come to fruition in the next months and perhaps start to see some of these things landing in the language in 2024, 2025, which will make a bunch of patterns easier. And obviously there's, asynchronous functions in traits, which is a major problem when you're doing asynchronous programming, because you wanna, you have an application, you wanna isolate a bunch of functionality behind an interface, which says, this is my database repository. And since your driver is async, that interface is gonna be async. But now the language doesn't support async traits. And then you're bringing a proc macro and the documentation is horrible. And, a bunch of stuff is like, that's not nice. So all these quirks, I hope in the next 2 to 3 years are gonna be resolved, or at least the major pain points are gonna be resolved. So the people that come to Rust and asynchronous programming, 2 years from now, have a very smooth onboarding. Things make sense because different parts of the language interact nicely with each other. You're generally not very surprised, and you don't need to know necessarily about how stuff is implemented. Like you can disregard, unless you're doing something advanced, a lot of the nitty-gritty, implementation details. So that's one side. The other side is the ecosystem, so the crates. Rust adopts a very lean policy when it comes to the standard library, which is the stuff is really, really, really core. We don't do anything else. So you're not going to fight anything HTTP related. You're not going to fight crypto in the standard library. All of this is, outsourced as well. What this means is that it really, the quality of Rust as a language really is tied to the quality of Rust ecosystem. If you don't have a good cryptography library, you can't do TLS. So do we have a good cryptography library? And I think in the last 3 years, a lot of foundational crates are coming to maturity, which means that they are fairly fully featured. Their APIs are fairly stable, even if they might be 0.x, which is a thing in the Rust ecosystem. And usually they're not going to have major, bugs or defects in them. The issues we have is some of these crates are no longer as actively maintained. as they were, because a lot of this work is being done by volunteers. And, perhaps you're doing a certain project at a certain point in time and you need a certain piece of functionality. You write it, satisfies your use case. Tomorrow you become an Elixir developer. You don't care about Rust anymore. Your library is abandoned. And this is a bit the NPM problem. Like, how many packages or NPM are actually actively maintained? And I think Rust, now that it's been on the high curve for a few years, is starting to see that abandonware like coming into the picture. Or like maintainers either don't have the time, the will, or the interest to keep maintaining some of these projects. And some of them might not be saved or contributed to by companies that step up to actually make sure that those foundational components are healthy. So that's a concern for a few libraries. For example, they're part of my own toolkit, and I think we're going to see them more and more as we go forward.
Yeah. Although I'd say that's a concern in any ecosystem.
Yeah, it's not special. Like, it's not special to Rust, but I think the Rust community might not be, as tuned in as others because it's very new. And so a lot of stuff was, in its glory days. It's like, this new library is, shiny and the maintainer is super responsive and it's full of features and it's amazing. And now, like, okay, 5 years have passed, what's happening to that library? You're seeing that now, which is fine. The other thing is, and this is specifically, for web development, a large part of what you do is integrating other projects. So you might be querying, the GCP API, you might be querying AWS API, you might be querying Vault from HashiCorp. And Rust as a language has not been mainstream long enough for a lot of these companies to consider, Rust as a primary concern in consuming their own stocks, which means that a lot of SDKs just don't exist. They're community maintained or they're experimental. And so this is a roadblock which I hope we're gonna remove in the next 2-3 years, as I think it's now became clear the Rust is established, is here to stay. People are gonna do more and more of it. Adoption is growing. So I do expect to see companies stepping in and say, okay, you want to consume, the Google stuff in Rust? Let's not task a bunch of random people on the internet with writing the GCP client. We, Google, are going to hire a team that's going to write the GCP client in Rust as it does in JavaScript, Python, and all the other languages. So I think that's going to be smoothed out, and it's great. Last but not least, I think when you start out an ecosystem from scratch, a lot of components are primarily geared towards making things possible, not necessarily towards making things streamlined. And so Rust has put a lot of effort into, now we have a very good async executor, and here we have a very good library to do networking things, and here we have a good parser, and here we have a good HTTP router. And all of this is great because then, you go there and you assemble all these Lego pieces and you build your tower of things, hopefully stable tower of things. That lets you do more complex high-level tasks. What I think is missing at the moment is something that takes a more opinionated approach, which is, all this like Lego complexity, very nice. But in reality, the first thing you want to do when you start a new ecosystem is not, go and do a thorough literature review of all the Lego blocks and, choose a block for each color. You want to get a stack, which is curated, that it works together, is documented as a whole, and that's the way you get into it. And then this is the major missing block at the moment in the Rust ecosystem for web. Like, you have a lot of micro frameworks. So to use a comparison from other ecosystems, you have Express in JS, and you have Flask in Python. But you have no Django, you have no Rails, and you have no Phoenix. This is not because, for lack of ambition, I think, from the maintainers of some of these crates. It's just that when you are bootstrapping the actual things, it's very difficult to tackle a scope which is much larger. But as the building blocks solidify and they don't require as much engineering and maintenance, then I think we'll see the possibility of merging of frameworks with broader ambitions and perhaps more opinionated. And this is where, for example, some of the activity I've been doing comes into the picture. Been working on Pavex, using the Italian pronunciation, which is a framework for doing backend development, which is very similar in many ways to ASP.NET Core. So it comes with dependency injection, comes with auto wiring, and in general tries to be a Rails-like framework. Like, the idea is this is going to be a one-stop shop for 90% of the things that you do in backend. It's going to have facilities for doing background tasks. It's going to have facilities for interacting with the database. It's going to take opinionated stance in the way you manage database connections. It's going to come with sessions and all the things that you usually want in a internet-facing, web backend for web API to have. And they're not going to be obscured in a bunch of packages. They are going to be core, and they're going to be part of the framework. But the reason I can, try and step in to do that is because, when I need to write the sessions, I don't need to go and write the cryptography, for example, to sign a session token.
Yeah.
That's there off the shelf. I can pick it and I can integrate it. If you go back 4 years, that was not as easy. And so you're like, whoa, that's just too much work. So that's where I'm coming from. I also have a slightly, camera blip again. So that's where I'm coming from. I also have a slightly, lukewarm take, which I think some people might disagree with, which is some libraries are going a bit too heavy on the type machinery at this point in time in Rust. Just because you can doesn't mean you should. And I think that for something like backend development, perhaps is making the onboarding experience too complicated for people, like too much generics, too complicated uses of trait bounds, compiler errors, which are very difficult to interpret because, you're doing a lot of like compile time checks through traits and bounds. And so that why Pavex goes in a very different direction and tries to keep things as vanilla as possible, in such a way that with basic Rust you can get productive, which I think is what should be possible. Like, I think Rust is a big language, and it's a big language because some areas require certain types of features. That doesn't necessarily mean that, to do a hello world application with a database and 4 things that should require in-depth understanding of traits and lifetimes. So we'll see how that goes. It's on GitHub, working on it at this point for 6 months, still not very functional. I hope to get it very functional by the summer, and we'll see how that is received.
Yeah, I think that's a nice closing statement also, sort of, right? Like overall, sort of the foundation is there, foundation is stable, and from now on, sort of things can only get better, get more approachable, get easier essentially, but still sort of you get all of the huge advantages, as we said before, right? Like reliability, performance, efficiency, and so on, right? So it's a great time probably for people to get started with web dev in Rust, which is also why we made the decision sort of to focus on that as a company.
Yes, it is.
Luca, thanks for joining today. I think that was a great conversation. I assume people who want to talk to you about all of this can maybe meet you at Eurorust in October.
Yes, they can.
October 12th and 13th. Tickets still available. Yeah, thanks again for joining, and talk soon.
Yeah, thanks to you for having me.